Good morning to all. Since long back, I am not with touch of you. Because in my old age, nowadays, more than 50% time I need for my weirdness. So, more than 50% time I am feeling unwell, uncomfortable. However, today I am not able to complete some laboratory important test, and today I want to discuss on consolidation properties of soil. Consolidation is an, in a word, it is a safety license of all structures because soil has a nature of compressed under static or any type of load. Normally the soil are raised over or on soil or rock of our lithosphere. In this system, we need basically two references. One is unit pressure, ultimate unit pressure, technically or shortly which we call QA plus minus m by z. It shall be more than the SBC and more than 0. This is shear failure criteria, and other is settlement within the permissible limit. We are seriously concerned about settlement since there is no provision of safety factor in settlement analysis like our shear failure. Alternatively, we are accepting a safety factor of 1 because there is no codal provision, and another condition is shear does not give any time for any kind of signal. All of a sudden shear may take place. So, there are safety factor of 2.5 or 3. Earlier, some experts they are suggested that the safety factor may not be 3. Then there are a lot of human errors in computation or in collection or in testing procedures or anything. There are errors because we are all human. Human is not a machine. We have some mistakes. On the other hand, settlement gives sufficient time to tackle the situation further. Nowhere 100% estimated settlement so far been reported. Since we are estimating settlement not confirmed like that of shear failure. Shear failure, yes, shear failure we noticed. Visually we see what is the type of shear at what stresses shear is there, shear took place, we noticed it. So we should aware of error of that our test. So we are applying shear, applying a sufficient safety factor against shear failure. But in case of settlement, we do not predict what shall be the actual settlement. In a study, it was stated earlier that till now, actual settlement in the complete lifetime of a structure, it is around 30% of the estimated settlement. A scholar was published later. In that stated that it is maximum of 30%. However, I am not defending that this settlement should not be addressed at all. Settlement may take place. During my long professional life, many settlement cases I have been associated. But all these are our own creation. We fail to forecast the consequence of our misdeed like careless stress distribution or the stress soil, many unplanned loading conditions, shifting of CG line of structure and foundation, and accidental poor workmanship, etc. I am sure that all structures are safe if all stages perfection is maintained. Here I want to add one thing. Main demerit is poor workmanship. A good design with bad workmanship and a good design with bad workmanship, there is a difference. One expert long back he was expressed his great dissatisfaction over poor construction rather than very good quality design. However, I shall discuss this later on in a day as I am planning to discuss on consolidation test today. The consolidation is the process of decrease of volume during peripheral constrained state due to drain out of poor water and air and subsequent soil structural changes under pressure. On the other hand, volume decrease without draining out of poor water is compaction, which can be mechanically be made, which can be statically made. Anyway, it is compaction when three-phase soil is a three-phase material, solid, that is soil portion, water and air. Saturated soil must under stressed conditions has a tendency of draining water and air gradually under stress of existing overburden pressure, which increases with time and finally produce structural changes. These structural changes are particle rearrangement or particle breakdown. In some advanced countries, it is called mineral breakdown. The theory of consolidation was first introduced in 1920 by Carl Tarzaghi and Paul Pflüger based on two different principles: hydraulic conductivity of soil and mixture of solid and liquid. These are both different concepts. And together both concepts, the final output was consolidation test. Nowadays, no one can ignore the importance of the consolidation test in geotechnical engineering and construction engineering too. Consolidation test generally conducted on clay, undisturbed or remolded soil samples, preferably granular soils are not the pore where the pore water is very easily can drain out. In that type of soil, consolidation test is not required. This test, ASTM had approved the test methodology in 1965 under ASTM D 2435-04, and BIS, fortunately, BIS also accepted in IS 2720 part 15 in the same year. Of course, little language changes or wording changes are included, but there is no major changes till now. The object of consolidation is to estimate the basic input data of settlement analysis of soil on application of stress. These are compression index, which is known as CC, compressibility coefficient, MV, AV, coefficient of volume change or volume compressibility is MV, coefficient of consolidation is CB, and time factor square root of T. See, this is the consolidation arrangement. This is the consolidation, this is machine, this is December, this is December, sail ring where soil is there, and this is the water tank, this is the loading device, porous plate at top, and here, in between, sample is in between, above one porous plate and bottom one porous plate, and steel plate at bottom, perforated steel plate, one at bottom, one at above, and here it is, hard steel plate is there, where one steel ball is there for direct contact with the loading arm. And this is the dial gauges. This gentleman is recording. So this is the process. The consolidation test details include test specimen setting up, nominal initial loading, keeping minimum setting time not more than 24. The initial settle time was said that it should not be more than 24 hours. But minimum, there was no mention the minimum. So definitely it will be 24 hours with a nominal pressure. And the test may be started with the initial loading. The dial reading may preferably recorded at 1 minute, 2 minute, 4 minute, 8 minute like that up to 24 hours. For each reading, it should be going for 1 minute to 24 hours. The loading shall be progressively increasing in pattern 0.5 kg, 1 kg, 2 kg, 4 kg, 8 kg, that or more. You can go for hard clay, you can go for 10 kg also. And after that, the release of loading following same pattern with same dial reading, that is time factor, may be made. After completion of the test, the soil moisture of the tested specimen may be estimated to obtain the void ratio E0 of the test specimen. The equation is this: E0 equal to Z0 into soil moisture into 0.001. No, 0.01. This E0 is also has some close relationship with compression index. Huff had established the relationship in 1957. As per his opinion, CC compression index equal to E0 minus 0.27 whole into 0.3. Nowadays, it is also included in the IS or ASTM. ASTM included means it is everywhere accepted. So, now if somebody says that there is no necessity of going for conducting test, yes, this equation is sufficient to calculate the, I have personally verified about more than few thousand consolidation tests I have conducted in my life, but difference is almost, it is 0.95 or say ultimately it is 5% plus minus 5%. In some soil it is 5% plus minus 5%, not more than that. So we can easily accept this method. However, my humble submission that a test is more better than thousand wise opinion. Dr. Carl Tazagi, he himself said, a test is worth than a wise opinion. I am adding there thousand wise opinion. Because you see, when I conduct the test, I see other phenomena also, which I cannot see in this equation. Without applying this equation, I cannot give that statement which I can easily see in a test under process. The results are recorded using IS result sheets. In this result sheet are all textbooks. These are available to, to derive the final output. There are two principal methods for reporting, and out of that, best one is void ratio by height, and next is change in void ratio method. Accordingly, graph sheet, both semi-log and normal graphs are used. However, E log P, EP graph is best in semi-log graph. This is the semi-log graph. So 1, 10, like that, 0.1, 1, 10. So this is the semi-log graph. This is E void ratio, and it is P, log P. This is the tabulation sheet. These are some data, basic data, height, area, specimen, volume, specific gravity, HS, E0, E minimum, P0, this is 0.7, maximum P is 3, these are pressure is kg per cm square, and these equations are used. And from this equation, we can calculate this equation. This is 0.55 E0. Accordingly, from this equation, we can calculate the CC. This is AB, minimum pressure, original void. This is minimum void ratio. This is the pressure, initial pressure and final pressure. This is initial pressure, and this is the final pressure. This is the final pressure. This red line is during transferring, it is coming down, and it is also coming down because it is originally coming in this way. In this point this is here, and this point it is here. So using this, we can calculate this anything. I have already said that this E0, which is determined from the soil moisture content, After completion of the test, using that equation, in this equation, we have to calculate this E0, specific gravity, soil moisture. Specific gravity, soil moisture, that is soil moisture, not in percentage, it is in the, to convert this decimal I am putting here. It is, this is essentially, it should be recorded because that value is more important. That should be the minimum void index. For settlement analysis, or actually what we need, I have already stated that this CC value, compression index, estimated from E0 is also close to consolidated test results, but CC based on WL, it is entirely dependent on soil plasticity. High the plasticity liquid limit, automatically it will be more the CC, compression index. This is the and soil moisture. Because if it is highly saturated, normally high moisture, high plastic soil has a tendency to absorb maximum high soil moisture. So in that soil moisture, the value may differ. However, in case of hard clay soil, after careful observation of liquidity index, earlier it was termed as relative consistency. Now it is termed as liquidity index and consistency index. Sorry, I did mistake. It is consistency index is earlier it is relative RC, relative consistency, it is liquidity index. Observing both the test results, it is some simple calculation one. From both the method, this may be conservatively used. For the Tarzaghi in original equation of CC, Z equal to specific gravity equal to soil moisture content after draining out all pore water has a strong base. So we should, if some relative stiffness, very stiff, hard, that type of information, if we get comparing the soil moisture content, then we can, there is no problem if we use WL concept, WL minus 20 into 0.08 or 0.007, whatever it may be. But otherwise, I do not in favor of using liquid limit concept. For estimation of settlement of foundation or group of foundation, basically we need compression index CC for normally consolidated clay, and MV for hard pre-compressed clay, and ES elastic modulus, and uh, Poisson ratio mu for immediate or elastic settlement. Another major advantage of settlement process is 1 mm settlement. If 1 mm settlement is there, then for sufficiently the soil shall be hardened. The foundation soil base due to drain out of pore water, which is our windfall, which in turn reduce the magnitude of the settlement. I have nothing to give except my heartfelt love and my sincere best wishes. Please be blissful and contented life. I am always available at jcgogoi@gmail.com. I am saying again, jcgogoi@gmail.com. Please be happy, please be healthy and blissful and contented for all. Today also I am